Welcome back, Focus Learners. Today, we are embarking on a seriously fascinating explainer. We're going on a journey, starting right from the mechanical, nuts and bolts reality of today's artificial intelligence, and we're climbing all the way up to the theoretical future of artificial general intelligence, or AGI. So grab your notebooks, get comfortable, and let's break this whole thing down. But hey, before we get into the heavy tech, I want you to consider a kind of bizarre but totally relatable question. Could a computer make a cup of coffee? And I don't mean a fancy smart espresso machine that you just tap a button on from your phone. I mean an AI literally walking into an unfamiliar house, finding the kitchen, and brewing a fresh cup from scratch. Keep that seemingly simple human task right in the back of your mind. We are going to come back to it later, and I promise you, it perfectly illustrates the massive barrier between where AI is today and true human-level intelligence. All right, here is our roadmap for this explainer. 1. Meet the modern AI. 2. Inside the Transformer engine. 3. Teaching AI to behave. 4. The AGI Holy Grail. 5. Defining true intelligence. And finally, 6. The future of AI. Okay, let's jump right into section 1. Meet the modern AI. You know, it really can feel like pure magic when a chatbot instantly writes a poem or magically debugs your software. But we kind of need to shatter that illusion right off the bat. Large language models, or LLMs, well, they are essentially just giant statistical prediction machines. They are repeatedly mathematically guessing the very next word in a sequence. They don't actually know the final answer before they start typing. They just learn these incredibly complex patterns by digesting immense amounts of text, and they generate language that follows those exact patterns. So it's basically the world's most sophisticated game of autocomplete.
So how did we get to this crazy level of prediction? Well, back in the 1950s, early computer scientists were stuck using these really rigid rule-based systems. Fast forward to the 2010s, and we start seeing the rise of neural networks and word embeddings. This is where AI actually started representing words as numbers in continuous space to learn how they relate to each other. But the absolute game changer? That's right there at the end, 2017. Google researchers published a landmark paper called Attention is All You Need, which introduced the transformer architecture. And honestly, this single breakthrough is what made the massive explosion of modern LLMs possible.
Moving right along to section 2, inside the Transformer engine.
For an AI to actually process our language, it first has to translate it into math, and it does this using something called tokens. Tokens are basically these smaller, machine-readable units of text. They can be whole words, subwords, or sometimes even just single characters. This standardization is absolutely crucial. It shows exactly how AI takes our messy, unstructured human language and chops it all up into a numeric format, specifically these vectors of numbers called embeddings, so that a neural network can actually compute it.
Now, the absolute core innovation of that 2017 breakthrough, that is the self-attention mechanism. This right here is the secret sauce. Self-attention basically allows the AI model to calculate the relationships and dependencies between tokens, even if they are super far apart in a long paragraph. It flexibly weighs how important different words are to one another. For instance, if an AI is reading an essay about dogs, self-attention helps it realize that the word bark is closely tied to the word dog, and it should probably ignore the word tree. It gives the AI this deep, incredibly accurate contextual awareness. Let's dive into section 3, teaching AI to behave. So, how do we tame these giant engines? Well, there are 3 major steps in the training pipeline. Step 1 is pre-training. This is where the model is just devouring billions, sometimes trillions, of words from books, articles, and websites to build up broad general knowledge. But a raw, pre-trained model? It's wild. It's totally unpredictable. So we have to move to step 2, supervised fine-tuning. Here, humans step in and provide a smaller set of labeled examples to adapt the AI to do specific things, like summarizing text or answering direct questions. Finally, we hit step 3, reinforcement learning from human feedback, or RLHF. This is where humans actually rank the model's outputs, teaching the AI to prefer responses that are helpful, polite, and align with human values. And that whole pipeline, that is exactly how raw data transforms into the polite little assistant you chat with today.
Which brings us to section 4, the AGI Holy Grail.
Okay, the really crucial point here is understanding the massive conceptual gulf between these different systems. Because everything we have today, from self-driving cars to chatbots to the AI that famously beat the world chess champion, all of that is what we call narrow AI. They only show intelligence within super specialized domains. An AI that plays masterful chess literally has no idea how to fold your laundry.
Artificial General Intelligence, or AGI, on the other hand, represents a totally flexible system that can match or even exceed human capability across literally any task. No domain restrictions, just pure general adaptability. And to really hit the nail on the head about how difficult that leap is, Meta's chief AI scientist, Yann LeCun, points out, a system trained on language alone will never approximate human intelligence. Wow, that is a sobering reality check, isn't it? Just scaling up these large language models and feeding them more and more text is not going to magically spawn human-level common sense. They don't have a persistent memory, they can't do hierarchical planning. Language alone, as impressive as it is simply not enough.
Quick aside here, because people confuse this all the time. AGI is not the same thing as strong AI. AGI is all about practical capability. Can the machine do the task just as well as a human? Strong AI, however, is a philosophical requirement. A strong AI would actually possess true consciousness. It would literally be a mind, rather than just simulating one. They are definitely complementary concepts, but an AI could theoretically achieve AGI, doing everything we do, without ever actually being conscious.
Now for Section 5, Defining True Intelligence.
Cognitive scientist Gary Marcus proposed this really fascinating set of benchmarks. To prove true general adaptability, a single AI system would need to pass all of these. Watch a movie and actually understand the character motivations. Read a novel and answer insightful questions about it. Work as a competent cook in a totally random kitchen. Write 10,000 lines of bug-free code completely from scratch. And finally, convert natural language math proofs into symbolic form. I mean, just rapidly reading through that list highlights just how insanely varied human capability really is. There's literally no single text-based chatbot today that can do all of these things, especially not the cooking part.
And hey, that brings us right back to our opening hook. Apple co-founder Steve Wozniak famously proposed the coffee test. For a machine to walk into a kitchen it's never seen before and make a cup of coffee, it requires something totally different: physical intelligence. It has to know what a kitchen is, spot the coffee machine, figure out how to open the cabinet drawers, and basically draw upon an embodied physical experience of the actual world. It vividly illustrates why true AGI is almost certainly going to require robotics and real-world learning, not just processing text on a server farm somewhere.
Finally, Section 6. The Future of AI. 2047. In a recent massive survey of over 2,700 AI researchers, this was the exact year they estimated there is a 50% chance of unaided machines outperforming humans in every possible task. That is only a couple of decades from now. But you know what's really wild? This forecast is actually 13 years earlier than experts predicted in a similar study just 1 year prior. The pace of this advancement is radically accelerating.
But hold on. Before you go marking your calendars for 2047, I want you to keep this historical fact in mind. Back in 1901, Wilbur Wright proclaimed that men would not fly for another 50 years. Well, just 2 years later, he and his brother Orville invented the airplane and took flight. The point here? Expert predictions, even when they are talking about their own disciplines, are famously flawed. The horizon of artificial general intelligence could approach much, much faster than anyone is anticipating. Which leaves us with one final, totally provocative question to ponder today. If an AI eventually learns to understand the physical and intellectual world exactly like we do, if it's capable of performing any economically valuable work, navigating physical spaces, and learning brand new tasks instantly, what will it actually need us for? What becomes humanity's ultimate role in a shared future with minds that outpace our own? I want you to really think about that, focused learners. Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll see you next time.